do a quick review of a couple of questions that were on the lesson quiz. They both had to do with box plots, and these were the most missed questions that you had on your lesson quiz. I think this was number 3, and this, yeah, that was number 3, and this one was number 4. So number 3 says the box plot shows the ages of people at a movie screening. What percent of the people are between 20 and 37 years old? Here's the thing you need to know about a box plot. A box plot easily shows you the median. The median is the middle value in your box plot. That means that half of your data lies below the median and half of your data lies above the median. Median is a type of average, but it's not the type of average where you add up your data points and divide by how many you have. It's the type that splits your data exactly in half. A box plot also shows you the first quartile and the third quartile, and another place where half of your data lies, above and below the median, but also between these two quartiles. Half of your data will be between those two quartiles. That's your most average half of the data. The middle of your data is going to lie between those two quartiles. If you subtract Q3 minus Q1, that has a name. That's called the interquartile range. It's a measure of spread. It tells you how spread out your data is. So we have the median. Half the data lies below the median. Half the data lies above the median. We have Q1, which divides our data so that the bottom half is in half, and Q3, which divides our data so the top half is in half. All of these numbers, and then we also have the minimum and the maximum value. The other thing that's easy to find in a box plot is if you subtract the max minus the minimum, that gives you the range of values that you have in your box plot. But anyway, those 5 values, the minimum, Q1, the median, Q3, and the max, divide your data so that 25% of your data fall inside of each region. Some regions are wider, like this is a very narrow region. This region is a little bit wider, but still the same number of data points falls inside of each of those regions. One thing we can't tell from a box plot is we can't tell how much data we have. We can only tell where our data is divided into quartiles. We can tell the percent of the data that falls within each of those quartiles, but we can't tell by looking at this box plot how much data we had to work with originally. They'd have to tell us that piece of information. Okay. The question they asked us for number 3 was, what percent of the people are between 20 and 37 years old? Well, here's 20, here's 37. So in this area, we have a 25% and another 25%. So the answer to the question is going to be 50% of our data falls between 20 and 37. And not only that, it's the middle 50% of our data. It's the interquartile, between the third quarter and the first quarter. First quartile and third quartile. Number 4 asked, which of the following data displays does not show individual data values, but rather shows the number of values that fall within a series of specified ranges? The most common missed answer, and possibly the only missed answer, was box plot. Box plot does show the percent of values that fall within certain ranges. Like I can definitely see that 25% of my data falls between 20 and 3, but I don't know how many values that is. It doesn't show the number of values. It only shows me that 25% of my values are in there. So the answer that's the best for this question is histogram, because that shows the exact number of values that fall within a series of ranges. The ranges for a histogram would be evenly spaced rather than these box and whisker plots are based on our data. They're not evenly spaced, but for a histogram, they'd be evenly spaced. But we would be able to go backwards from a histogram and say, I know exactly how many fall within that range. All right, hope this helps understand box plots a little bit better.